Limits of indeterminate form. Evaluate limit of the function 1 over 1 plus h minus 1 divided by h as h approaches 0. So first step in determining limit of a function is to substitute the value, the limiting value, and check the answer, right? Sometimes you get the limit there and then. So let's put 0 for h. Then what do we get? We get 1 over 1 plus 0 minus 1 over 0, right? Which is 1 minus 1 or 0 over 0. Now 0 over 0 is not defined in mathematics, right? And what we notice is that when we are trying to substitute the value, the limiting value, then we get the indeterminate form 0 over 0, right? So that means the function is not defined at the limiting value. That means function is not defined as h approaches 0. So at that point, the function is not defined. Now, it may have limit there, right? To evaluate the limit, we need to simplify this function and then find the limit. So let's do the simplification process. So we'll just simplify this function and then evaluate the limit. So we write here limit of this function 1 over 1 plus h minus 1 over h as h approaches 0. So let's take the common denominator and simplify the numerator. So we get 1 plus h, and here we get 1 minus, within bracket, 1 plus h. So at times I have seen students don't place brackets here and they get a wrong answer, right? And this could be written as limit h approaches 0, and 1 minus 1 is 0, and minus of plus h is minus h. So we get minus h over 1 plus h comes in the denominator times this h, right? And that gives us a value, limit of h approaches 0. And now we can cancel these h and h from the numerator and denominator, and what we get is minus 1 over 1 plus h. Now you can see it was this factor of h in the numerator and this factor of h in the denominator which was giving us 0 over 0. So whenever you get 0 over 0, that means a factor h is there in the numerator and the denominator, right? Now by simplification we isolated it and cancelled. Now we can substitute h equals to 0 and find or evaluate the limit of the function as h approaches 0, right? We should write here that h is not defined at 0, right? So when you do that, you get minus 1 over 1 plus 0, which is minus 1. And therefore, the limit of this function as h approaches 0 is minus 1. It is to be noted that the function is not defined as it approaches 0. We have a hole there, but it is approaching a value of minus 1 from both the sides, and therefore the limit exists. And therefore, limit of the function as h approaches 0 exists, and it is minus 1. Okay, so that is our answer. Thank you.